Why Tesla needed the Giga Press. Hello lovely YouTube family, welcome back to Tech IQ. In today's video, we are going to talk about why Tesla needed the Giga Press. Before we start, I would want you to hit that red subscribe button so that you never miss out on any of our videos. Giga Press are a series of aluminum die casting machines manufactured by Hydra Group in Italy. They are notable for being the largest high-pressure die casting machines in the world, with a clamping force of 55,000 to 61,000 kilonewtons, 5,600 to 6,200 TF. Each machine weighs 410 to 430 tons, 900,000 to 950,000 pounds. Base specification GigaPress machines had been included in Hydra's catalog since 2018, with usage of a customized OL6100CS GigaPress started by Tesla Inc. in late 2020 for the production of chassis parts for the Tesla Model Y. Shots of molten aluminum weighing 80 kilograms or 180 pounds are injected into the cold chamber casting mold with a velocity of 10 meters per second, 22 miles per hour, 36 kilometers per hour. The cycle time is 80 to 90 seconds, allowing an output rate of 40 to 45 completed castings per hour, or about 1,000 castings per day. Tesla's innovative new chassis design is one step closer to series production. The first Model Y mega casting has come out of the enormous Hydra Gigapress at Gigafactory, Texas. Tesla will combine front and rear mega castings with its new structural battery pack to form the underbody of Model Y. Current automobile chassis are made up of tens or hundreds of individual parts, which are made of many different materials and must be joined together in several different ways: welds, bolts, and adhesives. Tesla's plan is to use two huge single castings for the front and rear underbody sections and to connect them with a battery pack that serves as part of the body structure. This innovation reduces weight and greatly simplifies vehicle assembly. Cast components are a staple of auto manufacturing, but the norm is to cast smaller parts, which are then assembled into larger structural elements. As Elon Musk tells the story, one day he was considering a die-cast toy car on his desk and wondered what the practical size limit for a casting would be. After some research, he learned that there really is no size limit and decided to fabricate the front and rear underbodies of a vehicle as two huge castings with huge machines made by Hydra Group. Principle of operation: GigaPress in closed position during casting, plus after removal of previous casting, and in open position for robot removal of casting plus cleaning. Die casting works by forcing molten metal alloy inside a reusable mold, then opening the mold to remove the finished piece after it has solidified. The open mold is cooled to 185 degrees Celsius, 365 degrees Fahrenheit, and cleaned by robots, and fresh molten aluminum is prepared for the next cycle to begin 1 to 2 minutes after the first cycle. Each fresh casting is trimmed to approximate size, measured, checked for imperfections, and sent for CNC machining to finished size. For the Tesla's GigaPress-based casting operation, ingots and offcuts of aluminum are melted in a natural gas-powered melting oven operating at 850 degrees Celsius or 1,600 degrees Fahrenheit until liquid. Slag in the form of aluminum oxide is mechanically removed from the surface, and the rest of the liquid metal is pumped through heated pipes to an enclosed warming oven operating at 750 to 850 degrees Celsius, 1,400 to 1,600 degrees Fahrenheit, heated using 400 kilowatts or 540 horsepower of electrical power. To prevent the formation of oxides, a tank blanket of nitrogen gas covers the molten aluminum, which is circulated to maintain an even temperature. Argon gas and a rotary degasser are used to remove impurities, with a silicon carbide filter removing most other particles larger than 25 micrometers or 0.98 thou. At the beginning of each casting cycle, robots spray 35 milliliters, 1.2 imperial fluid ounces, 1.2 US fluid ounces, of soybean oil in a thin layer inside each half of the mold to allow separation. The mold is closed, and a low vacuum of 50 millibars, 50 HPA, created by pumping out the air from inside. A precise amount of molten metal is pumped from the holding oven into the casting chamber of the GigaPress at 750 degrees Celsius, 1,400 degrees Fahrenheit, and forced into the mold using a high-speed plunger with an additional 8 milliliters, 0.28 imperial fluid ounces, 0.27 US fluid ounces of lubricant. The mold is opened and the raw casting removed at 400 degrees Celsius, 750 degrees Fahrenheit. A robot reaches in and removes the casting, placing it in a quenching tank to reduce the temperature from 400 to 50 degrees Celsius, 750 to 120 degrees Fahrenheit. A mechanical trim press cuts the approximate edges, with excess aluminum being recycled back into the melting oven. The remaining useful part of the casting is X-rayed to check the internal structure, trimmed by laser, drilled for fittings, and then computer measured for accuracy. Die structure. Tesla's Model Y rear casting die has 4 known visible parts. 2 big classic main-facing dies, oriented vertically with injection from the bottom of the immobile one, 2 smaller side wedging dies, moving in for injection and out for removal. The front casting suggests an identical die layout, with maybe a 5th wedging die underneath, process, for the front-facing car crash rail mount. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.